Today on Macaulay Math, we're starting conic sections. Intro. Okay, good day. I'm Professor Macaulay. This is Math 150 Pre-Calculus, Lesson 38 on an Introduction to Conic Sections. Our goals for today. We're going to recognize the basic conic sections as intersections between a cone and a plane. We're going to write equations of parabolas in standard form, and we're going to use the reflective property of parabolas to solve real-life problems. This lesson introduces conic sections as the intersection between a cone and a plane, but conic sections have many applications in science and technology. Conic sections are often used to describe how planets orbit the sun and trajectories of spacecraft as they pass through the gravitational fields of celestial bodies. Let's get started. Okay, let's start with a definition. A conic section is the intersection of a plane and a double nap cone. Now what that means is just that you have two similar cones that are connected at their vertex. The conic sections that this course will focus on are the sections where the plane does not intersect with the vertex of the cone. Such sections are called degenerate conics. So in none of the conics that we will be talking about will the plane intersect through the vertex. Another way that we can define a conic section is through a locus of points. A locus of points is just a collection of points that will satisfy a certain geometric property. As an example, a circle is just a locus of points equidistant from a given point. Now the way you can think of that is if you go back to geometry, you have a compass. You set a distance on the compass. You put the point in your paper, that is the given point, and then when you run the pencil around that given point, all of the points that the pencil makes is the locus, the collection of all of the points that have the same distance away from that center point. Circle is the first conic section that we're going to be talking about, and the locus definition is the locus of points equidistant from a given point. If we were to define it as a conic section, the conic section, if a plane cuts completely across one nap, the side of the cone, and is perpendicular to the axis of the cone, the curve of the section is called a circle. So if I have this axis of the cone that goes down the middle of both cones, and I take a plane and I make it perpendicular to that axis, and I slice all the way through, that's why it's a section, it's a slice. And if it's perpendicular to that center line, then the resulting intersection between the cone and the plane will be a circle. And the standard form of the equation of the circle is going to be the quantity x minus h quantity squared plus y minus k quantity squared is equal to r squared, where hk is the center. And notice, positive h, positive k, and then they make them negatives here. We've dealt with that in the past, so just keep that in mind. And r is the length of the radius. So r is the radius, but in the standard form of the circle, and this is just some error management, in the standard form of the circle, it's r squared. For example, if this number here were 16, that's actually the r squared value, and the radius would only be 4. Going through a few more of these basic conic sections, just to introduce the remaining conic sections, although we're only going to focus on the circle and the parabola. An ellipse is a set of all points in a plane. The sum of the distance from two fixed points are constant, and I will show you an example of this in class when we get to the next lesson. But basically, instead of a single point like in a circle, if I have 2 points, any point on the ellipse, you could draw 2 lines to them, and the sum of those 2 lines would be the same. So if I were to draw, say, pick this point right here, and I take that segment and I take that segment, and I add those 2 segments together, it would be the same as this red segment and that red segment. Now, If we're to define it as a conic section, if a plane passes through the cone and isn't perpendicular to the axis of the cone, then it is called an ellipse. So if this angle right here is not a right angle, where it was in a circle, you're going to get an ellipse. The standard form for an equation of an ellipse is oversimplified. We will talk about it in more detail in the next lesson. Hyperbola is another conic section that we're going to devote a whole section on, which will be later. But as a locus, the hyperbola is the locus of all points in a plane. The difference of whose distance from two fixed points in the plane is a positive constant. And I'll show you what that means. As a conic, if a plane cuts through both naps of the cone, then the curve is called a hyperbola. And the standard form of the equation of a hyperbola looks very similar to an ellipse, except instead of a plus for the ellipse, we have a minus. And there are a few other differences. The second type of conic section that we're going to focus on today is the parabola. And the parabola is the locus of all points in a plane that is equidistant from a fixed point and a fixed line in the plane. As a conic, if a plane doesn't cut across one entire nap or intersect both naps, then the curve is called a parabola. And there are two types of equations for parabola. You have your vertical directrix and a horizontal directrix form. And the way that I tell the difference is, since this is the squared side, you'll have 2 y's for every 1 x. And when they flip-flop these two, you'll have 2 x's for every 1 y. Now, in this case, the h and the k turn out to be in the vertex. And if we look at this diagram right here, here are my 2 parabola equations. But the parabola is the set of all points in a plane equidistant from a fixed point called the focus and a fixed line in the plane called the directrix. So this vertex point right here is your h and your k. All right. And then the distance, I'm going to erase this right here. The distance from that to the focus is p units long. And when I say p, I'm talking about this number right here. And then the distance from the vertex to the directrix is going to be negative p units long. And you're going to measure that direction. Now, the vertex is always going to be at hk. The vertical axis directrix will be y is equal to k, and I mean that k, minus p. And when I talk about p, I'm talking about that p. And then the horizontal axis directrix will be x equals h minus p. And so since this vertex here goes through the origin, the directrix is p units below that vertex. That's a lot of stuff real quick. Let's go through some examples. First, it says find the standard form of the equation of a circle with endpoints of a diameter at -1, 2, and 7, 2. So first, let's recall the equation for the standard form of a circle. It is x minus h quantity squared plus y minus k quantity squared is equal to r squared. Now remember, h and k is the center and r is the radius. Now they're giving us 2 endpoints of a diameter. So let's draw a little diagram just to visualize what we're doing, and then we'll use that visualization to come up with a plan of action. But -1, +2. So if I go -1 here and I go +2 right there, there is 1 endpoint of a diameter. And then if I come over here to 7 and I go -2 here, there is another point. And the diameter connects those 2 points. So the center lies on the diameter. So somewhere right there is going to be our h and our k. So to find h and k, I need the midpoint. So recall my midpoint formula. And I'll go, your midpoint formula is x1 plus x2 all over 2, comma, y1 plus y2 all over 2. And let's see here. So I'll have -1 plus 7 all over 2. And I will have 2 plus -2 all over 2. That gives me a midpoint, which becomes the center. -1 and 7 is 6, divided by 2 is 3, and then +2 plus -2 is 0, divided by 2 is 0. Now this is my H and my K. So when I go to write my final answer, I'm just going to plug those values in. Now that I have found the center, I need to find a radius. The radius is either this distance there or the distance from HK to this point there. Does not matter which one that you choose. And so what I'm going to do is I am going to find the distance between these 2 points, and that will be my radius. So my radius R, and I'm just going to use the distance formula, which was x2 minus x1 squared plus y2 minus y1 squared. And so since I'm using the center and one of the endpoints, so I will go 3 minus 7 plus 0 minus -2 squared. That will give me the square root of, let's see here, 3 minus 7 is -4. -4 squared is 16. 0 minus -2 is +2. +2 squared is 4. That means that my R is equal to the square root of 20. Now, normally we would simplify that, but in this case, remember, we're eventually going to put R squared in there. So if I square R, the square root of 20 squared is just going to be 20. So now I know everything that I need to know, so I'm just going to plug that all back in. I'll have x minus 3 quantity squared plus, it would be y minus 0 quantity squared, but you would never write that as a final answer. So we will just say y minus 0 is y, and we'll square that. And then R squared we found to be 20. We'll put a 20 there, box around that, and I have found the standard form of the equation of a circle. Next example. This question asks you to write the equation of a circle in standard form, then find the center and the radius. You'll see that they have multiplied this out. This is called the general form. And to find the standard form, we are going to have to complete the square. Now, we completed the square earlier on in the semester, but we need to review. So for this one, to complete the square, the first thing that we're going to do is we're going to collect x's and y's. Now, if you look here, my x's are together, my y's are together. So in this problem, they've already done that for us. But in problems that you're going to see later on, you may have to do that. And since that's already been done for us, we will also in this step move the constant right. So I'll have x squared plus 8x plus. Now I'm going to leave a little room there for me to complete the square. And then I'll have plus y squared plus 2y. And again, leave a little room to complete the square for the y's. And we move this constant over. And since it's a positive 9, we'll subtract 9 from both sides. This 9 will cancel out and I'll have that. Now, for this one, to complete the square, I look at the b value for both the x's and the y's. And so what we'll do is we're going to add b over 2 squared. We're going to take that b, divide by 2, and square it. And then we're going to do that to both sides. We have to do it for the x's and the y's. So I'll have x squared plus 8x plus half of 8 is 4. We're going to square it. Plus y squared plus 2y. Now half of 2 is 1. And we're going to square that. And I have my minus 9 stays the same. But just like in any other algebraic situation, whatever you do on the left-hand side, you must also do on the right-hand side. So to keep this in balance, I have to add 4 squared and I have to add 1 squared. And so here I am going to complete the square. Now this expression here is a perfect square that we can write as a perfect square binomial x plus 4 squared. This is now a perfect square binomial which we can write as y plus 1 squared. And so I'm just bringing down these two numbers. That's why I didn't write 16 here and I didn't write 1 there. On the right hand side, I've got negative 9 plus 16 is positive 7, plus 1 squared is 8. And so this right here is my standard form. I then need to write the center. And again, remember, it's the value that makes both of these 0. So it'll be negative 4 and negative 1. And then my radius, well, the radius is equal to the square root of 8. And I can simplify this. So I'll have 4 times 2, which will give me 2 square root of 2. And so my final radius will be 2 square root of 2. We'll put a box around that and say that we're finished. All right, next one. It says find the standard form of a parabola that has a vertex at 2, 4 and a directrix at x equals 0. Well, as always, I suggest drawing a diagram. That usually makes your life easier and helps you create a plan of an attack. Now, I drew only the first quadrant because that's really all I need. If I go 1, 2, 3, 4, and I put a point right there, that's the vertex. Now the directrix is x equals 0. X equals 0 is a vertical line at 0. If you remember from our diagram up here, the distance from the vertex to the directrix is negative p units. So this distance right here is negative p, and also through the vertex is that parabola. Now, since my directrix is vertical, this parabola has to open away from the directrix. And this point here will be p units that way. All right, since I can measure this, if I go from my vertex to my directrix, I go back 1, 2. So this distance right here is negative 2. So negative p is equal to negative 2. With that, and since negative p is equal to negative 2, positive p has to be equal to positive 2. Now I know everything that I need to know to plug in, because this, if you recall, is your h and your k. I have my p. The only thing I have to decide is, am I using the standard form that starts with y minus k squared, or am I starting with x minus h squared? Remember what I said. This equation says I have 2 y's for every 1 x. This one says I have 2 x's for every 1 y. When I go back to this expression here, if I were to pick a point x, this has 1 x, and if I go up through there, I will get 2 separate y's. So here I have 2 y's for 1 x. That means that I'm going to use the y minus k quantity squared is equal to 4p x minus h. I have 2 y's for 1 x. All I have to do is plug in. I'll have y minus 4 squared equals 4 times 2. That's my p-value, times x minus 2. This 2 refers to that 2 in the coordinates of the vertex. I will simplify just a little bit because it asks us to leave the standard form without distributing or multiplying out the square. There is my standard form. All right, last question. It says write the following quadratic in standard form, then list the focus, vertex, and the directrix. And so again, we're going to need to complete the square. This one is a little different because there is no y squared. I know that it is a parabola. And because it's an x squared, I know that it's going to eventually be in this form here where I have x minus h squared and then y minus k. So that's my goal here. So to complete the square for this one, I am going to move the y's and the constant right. And so we'll have x squared minus 2x, and then plus, we'll leave a little space to complete the square. If I subtract 8y and subtract 9 from both sides, I'll have negative 8y and minus 9 on that side. Here, I'm going to add b over 2 squared to both sides. That'll give me x squared minus 2x plus half of negative 2 is negative 1. Here I am going to complete the square. And simplify. So this is now the perfect square binomial x minus 1 quantity squared. And I'll have negative 8y, negative 9 plus negative 1 squared. Well, negative 1 squared is 1. Negative 9 and 1 would be negative 8. And so I get it into this form right here. I'm going to factor out a negative 8. That'll give me x minus 1 quantity squared is equal to negative 8 times y plus 1. And so there is my standard form. It also wants me to find the vertex, the focus, and the directrix. And again, I would suggest drawing a diagram, but before I do that, since it's easy, let's read the vertex. It's going to be 1, negative 1. All right, 1 makes this 0, and negative 1 makes that 0. And so if I plot that point, just to give me a little diagram, general idea of what I'm doing, if I go 1, negative 1, I have this point right here. And since I have 2 x's for every 1 y, I know that this is going to open either up or down. Since I have a negative out there, I know it's going to open down. And if you want to check that, you can always go to Desmos and plug that in real quick. We might as well. We'll go x minus 1 quantity squared equal to negative 8 y plus 1. And we can see we have that parabola that opens down. All right, so to find the focus, that is a point right here. And I've got to figure out what P is equal to. Well, 4P from the formula is equal to this value right here, negative 8. So P is equal to negative 2. So if this point right here is 1, negative 1, then 2 units below that will be 1, negative 3. So 1, negative 3 goes there. My directrix will be 2 units above. So counting from negative 1 up 1 unit, 2 units, I'll have a horizontal line 2 units above 1, negative 1. Well, that'll be at y is equal to 1. And if we go to Desmos and I type in y equals to 1 and I type in 1, negative 3, that definitely, it looks like I have the focus in the correct place and I have the directrix in the correct place. So I'm pretty happy with that. Well, folks, after I put a box around this, that is all I have for today. So, Star Wars fun fact of the day. There are a lot of hands cut off in Episode 3, Revenge of the Sith. The most evil title has the most hands cut off. And so, just to review, Count Dooku loses 2 hands to Anakin. General Grievous loses 2 hands to Obi-Wan. Mace Windu lost 1 to Anakin, and that was a shame. And then Anakin lost a hand and 2 legs below the kneecap to Obi-Wan. Obi-Wan has the biggest count. Well, that's all I've got for today, folks. You have a great day. Goodbye.